Nanomaterials. Nanoscience is an emerging field of science which deals with the performance, phenomena, and manipulations of extremely small, that is ultra small materials. Ultra small materials coming under the range 10 raised to minus 9 meter. The properties of these materials are extremely different from the larger particles. The word nano is derived from the Greek word dwarf, which represent the dimension 10 raised to minus 9. What are the characteristics of nanoparticles? First property is, since the size is very small, it can overcome a large number of barriers. Then the next property of nanomaterial is large surface area by volume ratio. Large ratio of surface area to volume. Okay, these two properties makes them very effective. All the properties of the nanomaterials depends upon these two characteristics. That is very small size and large surface area by volume ratio. Now let us talk about the history behind the development of nanomaterials. So in 1867, the scientist James Clerk Maxwell, who proposed an experiment of tiny particle, and he named these particles as Maxwell's demon. Later in 1914, Richard Adolph Zsigmondy determined the dimension of these tiny particles, and he proposed that the dimension of this tiny particle coming under the range of 1 by 10 raised to 6th of a millimeter. In 1959, Richard Feynman he wrote a book which mentioned about the tiny particles, that is nanomaterials, and the name of the book is There is Plenty of Room at the Bottom. There is plenty of room at the bottom. And this book explored the possibility to study the materials at the range of or at the scale of atomic or molecular levels. Then in 1974, a researcher in Tokyo University named Norio Taniguchi Norio Taniguchi in 1974 introduced the word nanotechnology. And later in 1980, the scientist named Eric Drexler who proposed that nanotechnology can be introduced into the field of engineering, and he introduced this idea through the concept molecular manufacturing. And his vision was molecular nanotechnology. And he claimed that we can develop or we can prepare diamond from coal, and even we can prepare the silicon chip from sand. This was his claim. The scientific field, cluster science, and the technology called scanning tunneling microscope, STM, were developed during the beginning of 1980s. And these two, that is the field is cluster science and the technology scanning tunneling microscope, helps the development of nanotechnology. Develop nanotechnology a lot. And in 1985, Buckminster Fuller developed a prepared material, cluster material called fullerene, which also helped development of nanotechnology. And this was developed by Buckminster Fuller. Later in 1990s, the preparation and purification of fullerene was done by Huffman and Kreitzer. Now let us talk about an unusual optical device which was developed in 4th century AD. And that optical device is known as Lycurgus cup. This Lycurgus cup was developed by the Roman glass workers. This is a dichronic cup. Dichronic means it shows two different colors. That means in reflected light, it shows one color, and in transmitted light, it shows another color. That is, when light incident on the surface of this cup appears as green. But when light is transmitted through this cup, this appears as red. That is why this is known as dichronic cup. So this is the picture of a Lycurgus cup. One is ruby color or red color. The other one is green in color. This Lycurgus cup is otherwise known as cage cup or diatrita cup or diatrita. These are other two common names of Lycurgus cup. One is cage cup and the next one is ditrita. The dichronic property of Lycurgus cup is so miserable. So later, so many scientists studied about the composition of Lycurgus cup. But the exciting thing is that the composition is Lycurgus cup is same as that of modern glass. That is, the modern glass as well as Lycurgus cup containing silicon dioxide, silicon oxide and calcium oxide. So if we compare the amount of these compounds present in Lycurgus cup and modern cup, silicon dioxide about 73% was present in Lycurgus cup, and in the case of modern glass it is about 70%. Then silicon oxide is about 14% in Lycurgus cup, while it is about 15% in modern glass. Then in the case of calcium oxide, 7% in Lycurgus and 10% in modern glass. But modern glass does not show the dichronic property. Dichronic property is not shown by the modern glass materials. So what may be the difference between modern glass materials and Lycurgus cup? After so many studies, scientists concluded that there may be the presence of the small amount of gold and silver particles in it. And the gold and silver particles are present in nanoscale range. And the red or ruby color of this Lycurgus cup is due to the presence of gold nanoparticles, and the green color is due to the presence of silver nanoparticles. The amount of gold particles is in the range 40 ppm, and silver nanoparticles is in the range 300 ppm. Scientists tried to recreate the Lycurgus cup again, but the preparation was not that much successful. The scientists coming to a conclusion that maybe the concentration of the Lycurgus cup and the modern glass may be different. So concentration may be different, or the conditions when the Lycurgus cup prepare may be extremely different from conditions in which we are preparing our modern glass. So atmospheric conditions may influence the formation or the dichronic property of Lycurgus cup, or maybe due to the colloidal dimension of gold and silver particles arises the dichronic property of that Lycurgus cup. Maybe the proportions or the oxidation state of the trace metals present in Lycurgus cup may be entirely different from the glass materials we are preparing now. So these reasons may leads to the unusual optical properties of Lycurgus cup. That may be the reasons leads to the failure of the recreation of Lycurgus cup. Okay. Then next one, a roll of nano gold. In traditional medicine. Swarna Bhasma is used by our traditional people for therapeutical agent. Therapy in the sense this Swarnabhasma is used for the treatment of asthma and rheumatoid arthritis and diabetes for some nervous diseases, etc. Then next one, Saraswata Arishtam. Saraswata Arishtam is medicine which is used to enhance the memory power. Saraswata Arishtam was used for memory power enhancement, to enhance the memory power. Then it is used to enhance the mental ability of children. If we talk about the applications of the gold nanoparticles other than in India, Egyptians used gold nanoparticles in dentistry, and in Alexandria, alchemists developed a colloid, gold colloid, and they called it as liquid gold. And they believe that this colloidal solution, liquid gold, can restore youth. Okay, these are all about the medicinal uses of gold nanoparticles in old days. Then if we talk about the color of gold nanoparticle, the color of gold nanoparticle was proposed by Faraday, or that was experimentally found out by Faraday. Faraday proposed that the ruby color of gold is due to the colloidal formation of gold nanoparticles. Actually, he studied the color of large number of metals, but his main interest was gold. He studied the color of gold particles by taking sodium chloroaurate. Sodium chloro. He added some reducing mixtures containing phosphorus and carbon disulfide in diphase system. So his observation was the yellow color of this sodium chloroaurate converted into ruby color. And his conclusion was the ruby color is due to the formation of gold colloid in this. So later the experimental conclusions and observations by Faraday was proved by Turkiewicz by using electron microscope. He found out that the colloidal dimension of the gold particle is about 6 plus or minus 2 nanometer. Okay, this was all about the history of nanoparticles.